digital signage is everything that we see around us, the screens that inform us about something.
And according to your experience, is vandal proofing an actual issue?
It's not a huge issue. It's like the service matter. It's like everything what is out there can be kicked from time to time. So the stronger we do it, the more, let's say, safe we are. Yes.
Hi, Kamil.
Hi, Wojtek.
I would like to talk with you today on selecting displays for public space devices and or digital signage. Could you please start with some explanation and comparison between digital signage and public space?
Basically, digital signage is kind of application that inform us about something. It could be an advertisement, but could be a weather condition or like maybe a bus stop that is showing the traffic. I mean, where the buses are, when they will come, etc. There will be a gallery where we'll have some information, but also we will have advertisement in general. So digital signage is everything that we see around us, the screens that inform us about something. And then the public spaces is a more general term, and in this term we put more displays and the devices that typically we interact with. That could be an EV charger or maybe a parcel terminal. When you have a parcel terminal and you want to receive the package, typically you need to interact with the screen. So the screen is smaller, maybe there is no advertisement, or it could be advertisement, of course, but the general use case for the screen in the parcel terminal is more to interact with you, to open the box and to take the package, not to maybe inform about something like the weather or other
Okay,
things.
so the difference is, I guess, in function, because
in function, yeah.
we could say that, as I understand it correctly, that digital signage might be just a part of public space.
Yes, typically there are large screens that we see from the distance.
As we have it clarified, let's proceed and discuss a little bit the role of displays in the way you can enhance communications or navigation in public spaces, or even marketing, I guess.
Basically, digital signage or public spaces displays are a perfect example of how to use a display to enhance our lives, and that's why I love displays, because I strongly believe that they are giving us a lot. It's easier to live when you see the information and you have the clear information, and also the safety is higher because on the screen we can show a lot of information, but we can find something fast, like we discussed on the airports, etc. If the screen is large, clearly seen, bright, then from the distance even we can read it and know where to go.
So it makes our lives easier.
Yes, simply easier and better. Yeah? So, of course, sometimes maybe there's too much of screens, but in general, it makes our life better.
You gave us some application overview earlier. Could you give us some industry-specific requirements concerning displays in those devices?
Again, because we are outdoor or sometimes outdoor, or even if it's indoor, it's a gallery, still the requirements are a little bit different than the typical indoor use case like the office or even home. First of all, maybe focus on the indoor. If we are in the shopping center or airport or any other public transportation area, we need to expect that there will be a lot of light. So typically these areas are very bright as well. So the brightness of a display need to be higher than normal, and the minimum requirement typically 700 candela. Home monitor typically, or like a TV, typically will have 250 to 300 candela brightness. That's why when you have a lot of light going through the window, maybe you do not see the image clear. So 700 is like 3 times more than the monitor that you have on your desk. Mobile phones are a little bit tricky because they are often used also outdoor under the direct sunlight. So they have the mode that can increase the backlight quite strong. And some of the models can go up to 1,500 or even 2,000 candela to be clearly seen under the sun. Of course, it drains battery very fast and typically hit the telephone. So maybe you can work maybe a few minutes only with this high brightness. But yeah, it's way higher than the typical home application screen.
So all those places, whether indoor or outdoor, public spaces are brightly lit.
Yes. So first brightness, then the viewing angles. In public spaces, you need to expect that the display will be seen from all the sides, like up, down, maybe left, right. So typically for public spaces, we use only IPS displays, which have IBS or MVA. There are different technologies, but the effect they have the same for a user. That means you can see them clearly from all the sides. In home, you can use a TN display for your monitor. Its technology is called twisted pneumatic. It's the most basic technology for monitors, or like a TFT screen, but this TN have only 3 angles that are okay and are not that wide as in IPS, and 1 angle that is not good for a human to see because there is effect called grayscale inversion. After the certain viewing angle, the bright colors will become black or like dark, and the dark colors will become bright. So we have the grayscale inversion. The image is distorted for the human. But if it's a monitor, it's okay because you look on the monitor typically straight. Yes. Going back, we need high brightness for public spaces, and then we need all viewing angles.
How does it work with Riverdi displays?
Yes, we are prepared for that, and our standard displays, they are IPS and 1000 candela. So we are even more than enough to be used in the public spaces for standard products.
Okay, so moving on to some other requirements.
Mm-hmm. Yeah, there are more. If we stay indoor, then maybe the temperature will not be that important. Let's keep it aside for a second when we'll go outdoor. But indoor, one more factor will be important. That will be long-term and continuous operation. So when we have a typical indoor display, maybe for a coffee machine, etc., even if it's a professional coffee machine, that Riverdi is manufacturing a lot, by the way, it typically won't work 24 hours. So it work a couple of hours per day, maybe 12 hours per day, but not 24/7. But for the public spaces, we assume that the displays are working 24/7, because the airports are working 24/7 or train stations. Mm-hmm. So the display need to work continuously 24/7. That's why the requirement toward a long lifetime of a screen, and especially the backlight, is typically very high. Yes, in most cases for industrial displays, it's enough to have maybe 50,000 hours, and this is Riverdi standard. And for public spaces is enough, but in some cases the customers require even 70,000, or we have models of 100,000 hours. It's like about 12 years of continuous work. 24/7 with the full brightness.
So that's quite demanding parameter.
Yes, that's very demanding.
On one hand, you have to have bright backlight. Then on the other hand, you have to withstand some longevity.
Yes. So high brightness generate a lot of heat, and the heat actually decrease the lifetime of a LED backlight typically. So you need to control it very well. So the public spaces displays, they have a special design to remove the heat. If you work 24/7 with the high brightness, you need to remove the heat to keep the LEDs cool. And the cooler you keep them, the longer they will work.
And speaking of temperatures, could you expand a little more on outdoor?
Sure. So when we were indoor, the temperature is pretty constant typically. It doesn't concern that much. But if we go outdoor, then we can have a wide range of temperatures. Most of the TFT glass, typically, like your monitor on your desk, let's start here, can work maybe with 0 to 50 degrees only Celsius. So very narrow range. If you take the industrial display, you can go typically from minus 20 to 70 degrees. But for outdoor display, it may not be enough. So if we talk about public spaces, digital signage, current requirements are higher. And we need to have a special liquid crystal called high-TNI. That means high temperature pneumatic to isotropic phase. So it may sound complicated, but let me explain you. So to control the light that is going through the TFT display, we need liquid crystals to be in pneumatic phase. This phase means that we can control the polarization of the light. But basically, we can control the light. We can switch on and off the pixels and control how much the light is going through the pixels. Yes? So we can generate the grayscale. And this pneumatic phase is only in the certain temperatures. Like I said, 0 to 50 for your desk monitor. That's the cheap basic LCD.
Because it's liquid.
Crystals, yes, it's liquid, and it needs to be liquid. It needs to move. Then maybe minus 20 to 70 Celsius degrees for industrial. But for outdoor application, maybe we need minus 30 or minus 40 even. And we need a special glass for that. And in low temperature, it's not so bad. If we have a special glass, then we just need to prevent it from freezing, because it's getting, denser and denser until it freezes and the crystals cannot move and the image freeze. So we just need to keep it, let's say, liquid. But in a higher temperature it's harder because when you go with the temperature higher, the liquid crystal changed the phase from nematic to isotropic. And basically isotropic means the liquid become like a water. They do not destroy, fortunately, so you can reverse the effect if you cool down the screen. But in a higher temperature, they are not organized. They are scattered, let's say. Right. So you still can control them, but it doesn't work because all of them are not, basically, they are not organized. They need to be organized to move the light as you want it. And you need to move this nematic to isotropic phase as high as possible. And we have the special TFT liquid crystals that can work from minus 40 up to 110 degrees. So it's very, very high. But actually it's necessary because when you have outdoor display and you have direct sunlight, during the summer, the surface of the screen can go up to 100 degrees easily. So this kind of research are required nowadays for outdoor spaces.
And you provide it and you also test your displays?
Yes, of course. We test all of our displays. So we have our own environmental chamber. We can test with the temperature, moisture, anything that is related to environment.
It reminds me of this LED lifetime you mentioned before. Mm-hmm. Do you test it also in-house in Riverdi?
Yes, we can test the LED lifetime as well. So we typically use a high temperature test. So we speed up. The temperature is just the movement. So if you increase the temperature, there is more movement. So you speed the time.
Are there any more requirements like vandal proofing, I guess?
Mm-hmm. So it's a matter of protection. If it's just digital signage, so that means information display and no interaction with the user, then it's enough to put the glass. It's pretty simple because it's just a matter of how thick glass we will select. But if it's a display for a device that needs interaction with the user, so a touch interface, then we need to put the sensor behind the glass. And then we are back into the touch screens. And then you have to select the right controller and the sensor design to work with the thick glass, maybe water, and the gloves. These are, of course, important factors to take into the consideration when you design the outdoor device.
And according to your experience, is vandal proofing an actual issue in those applications? Like there are some customers who come back that they actually need those features?
It really depends where. Every country have different rate of the vandalism. So, of course, there are numbers. We know them from our customers. It's not a huge issue. It's like the service matter, yes? Everything what is outdoor can be kicked from time to time. So the stronger we do it, the more, let's say, safe we are, yes?
Okay. Thank you.
Okay, thank you. Thank you very much.